test saying, no one has 10 million messages. Rather than arguing with this dismissal, try the same test with less extreme values. If the search fails with 3,000 messages instead of 10 million, you have a bug that no one can dismiss. Now, if you can't replicate the bug with 3,000 messages, that's interesting. What is the smallest set of email messages that does make the search fail? The broader the range of values that trigger a failure, the harder it is to dismiss the failure. On the other hand, if the program does fail only on extreme values, now you know. Report it that way with the results of all your tests. If the project manager quickly defers the bug, that might be the right decision. I usually put the burden on the tester to do retesting when you find a bug with an extreme case. But sometimes it's too hard, too slow, or too expensive. The fact is that programmers do have better diagnostics than you. They have the ability to determine the root cause of the bug and analyze its repercussions, which you don't. So sometimes the right thing to do is to remind the programmers that what you see is just a symptom. I'm told that at Borland this was called the tip of the iceberg defense. The way that goes is, hey, this corner case, yeah, it's a corner case, but it might just be the tip of the iceberg. Do you know why this bug occurs? Do you know how serious it really is? Another common analysis for generality involves configuration dependence. When the program fails a test, especially if the failure looks like a coding error rather than a designed-in annoyance, what you know is that if you do these things with these data, with this program on this machine, you get a failure. Many people assume that if the program fails on their machine, it'll fail on almost any machine, so they don't bother with configuration testing. That's fine until you submit a bug that actually is configuration dependent and you didn't realize it. A bug will lose all credibility with the programmer, and you will lose credibility. If you submit a bug as a general occurring bug, but it only replicates on a few machines, none of those the ones on the programmer's desk. There are several levels of configuration dependence to consider. Think of testing a program like OpenOffice. Runs on lots of different operating systems. Imagine you get a failure on a Windows Vista system. If we switched operating systems, would we still see the failure on a Linux box or on Windows XP? If we stayed within the same operating system, would we still see the failure if you switched video cards or the amount of memory? Configuration dependence shows up under surprising circumstances sometimes. The oddest one that I ran into involved a program called Quicken, which does personal financial management. Imagine searching for a check that you wrote, except you didn't write that check. It's a non-existent record. Quicken would crash, but only if the keyboard driver was the Microsoft IntelliSense driver. What does keyboard driver have to do with a database search? I don't know, but that was the critical condition. In another case called Calendar Creator, we shipped with an odd configuration bug. It required a combination. You could work with very high-resolution displays, and you could print high-resolution printout. And it worked fine with both of those. But one of our customers did a print preview to a high-resolution display. Crash. I prefer to build my configuration testing automatically into my replication procedure. So when I test with two computers that are similar in their operating system. Maybe it's two flavors of Windows XP, or slightly more extreme difference, one's XP and one's Vista. Their main difference is in hardware configuration. Different amounts of memory, different hard disks, different keyboard drivers, mice, all that kind of stuff. Then I run the tests on the less capable computer, which is probably running the minimum amount of memory, the minimum amount of free disk space, and so forth allowed for this program. Is that's more likely to run out of memory, to slow down noticeably, or otherwise show that it's grumpy. I want a chance to see symptoms. When I find the bug on this less capable machine, I replicate on the faster one. When I write the bug report, I use one machine. It basically is a connection to the bug tracking database, while I repeat the bug on the other machine. So as I write each step into the bug report, I follow the instructions on the other machine. By following my instructions exactly, I test my bug report while I create it. So this is another way of doing a configuration test. If the replication fails while I'm reporting, then I do configuration-related troubleshooting. Another kind of generality test involves checking the age of a bug. When did this bug get introduced to the program? That's primarily useful when testing an update to the. We often do fairly narrowly scoped changes to a program, patches, to update some critical aspect of the program. And when we do that, testing is usually pretty constrained. Even if you find a bug that looks moderately serious, it's easy for people to argue that it shouldn't be addressed at this time because the scope of the update is narrow. There are two winning investigations. that you can do at this point. The first one is to prove that this bug is a new side effect of the most recent code changes. That immediately gets it considered because it's now right within the scope of the work done for the patch. The other is to confirm that this is an old bug, but find a lot of unnoticed complaints. Check with your help desk. Many customer complaints get classified as miscellaneous if they don't map to a problem that the support group is explicitly tracking. And that's especially true if customer descriptions are a little bit fuzzy. Once you know what you're looking for, you might find boatloads of complaints. And if so, that might elevate this so that it becomes part of the scope of this patch or of the next one. Up to this point, we've been focusing on follow-up tests of coding errors, direct investigation of the bug through testing. But in many cases, typically with design issues, the most effective report describes the problem in terms of the product's context. It's not further investigation of the failure itself. It's investigation of the competitive market, user needs, what the product fits in the middle of. But if you offer that kind of information, you have to be very careful to back your assertions with credible data. No one expects you to be an expert in anything other than testing. Even if you are an expert in other things than testing, no one will believe it most of the time. Too many testers before you have spouted completely uninformed opinions about too many aspects of too many products. So it's much more useful, instead of relying on your own expertise, to look inside the company for the credible source for the point you want to make. For example, if you want to argue that your product is going to generate bad magazine reviews, people might believe that if your company's public relations manager says it. If you want to argue that technical support costs are going to go through the roof, people might believe that. If the help desk manager says it, those are the credible sources. And your goal is either to get the credible source to give you a statement and data that you can quote in your bug report, or get them to speak themselves at the triage meeting. So it's not you saying this stuff. You're just quoting them, or else they're saying it themselves. They're the experts. Now, if you can't get that kind of statement from your company's in-house experts, you have to use public information instead. But be very careful to cite the books or the magazine reviews or the competitors' advertisements or whatever it is that you use. And don't stretch what you find. Other people can look them up. Lawyers talk a lot about the importance of credibility of your data as it applies back to credibility of you. The name for that in law is sponsorship theory. You're the sponsor of any evidence that you present to the jury. If you present weak evidence, like an unbelievable witness, the jury doesn't just think that that evidence is weak. They lose their trust in you for presenting that evidence. And that weakens your case way more than this particular piece of bad data. So let's sum up. We can have a big influence on how seriously our bugs are treated by expanding the testing we do when we find a failure, or by doing contextual research to help readers understand a bug's significance. Some people ask me how long to spend per bug. It depends. Some bugs are self-evident. They don't need any troubleshooting. On other coding errors, I usually spend 15 minutes. But if something happens during those 15 minutes that makes me suspicious, I might work on it for a day. Over time, you develop judgment, intuition about whether further research is likely to pay off or not. Similarly with design issues. Some are obvious, they can be justified pretty quickly, or you can get all the research that you need from a quick email to the right person. It takes 5 minutes. Others require way more research, and it may or may not be an important enough problem to justify developing all the information that you need. No matter how well you do your work, some bugs won't get fixed. That's okay. The goal isn't to get every bug fixed. Your goals are to help the project team select the right bugs to fix and to help them make their fix-related investigations more efficient.